I put up a fun little graphic as the thumbnail here. Say, don't do this. Now, don't do what? In the header or the description of it, it's why you should never, ever, ever actually use select star. And we're going to talk about all the ins and outs of if you actually write your queries with select star. Now, maybe you've already learned it, you figured it out. It was something, if you've been in production for a while, it's something that comes and slaps you silly if you are using select star, or if you have any kind of sustainment that you're having to maintain. If you've built a system and you've been there for a few years and you've had to go through evolutions, data schema changes, that kind of thing, where columns change, columns get added, columns get deleted. Though don't delete columns. Maybe that'll have to be a different episode of select star to talk about the ups and downs of making schema evolutions. But if you've dealt with any kind of morphing of your data, you come in, you started with a 20 column table, and by now it's at 100 columns of data have been added to a given table, and you're having to roll with the punches, if you will. If you've seen any more amount of that evolution, you may know what I'm talking about when I say don't use select star. And I hope you can appreciate the nature that that's the name of the show, is kind of an inside joke that I hope you can share with us. So what we're going to talk about in this episode, let's just pull that out, is what is it with select star, like why you should or should not do it. Now I brought in the oh, wait a minute, my trusty sidekick here. I got my iPad here as my nice whiteboard. Make sure we got oh, let me get I need a layer here. Okay, you're seeing all the insides here. Okay, now we've got something here. What is that? There's a line here popping up. Okay, let's do this. Okay, so we can follow along here. So what we're talking about is something where you're doing a select star, and you got some kind of thing like if you got some kind of online bookstore or whatever, you're selecting, you're fetching all the data from your book table. Now you've already learned your lesson. You need to put a where clause on it. Okay. If you select every column, if you select every row and every column from the database and you have 10 million, 100 million rows of data, you're going to be waiting a long time. It's going to take you a while for that to come back. So you put some kind of where clause to filter it down. Maybe where the author is, I don't know, yours truly. Okay. Do something like this. Okay. So it's going to look for one row. Okay. Well, or 9 rows. Okay. So you're fetching, what are we doing here? We're doing a select star. That means give me every column. Now it's, in this context, it's a single table. It's every column from this table. And we filtered it down to this particular author. Hopefully it's also indexed. We have other videos in this series where we talk about optimization and ways to improve that. So hopefully there's some kind of index that basically this query is pretty fast. So we're not talking about performance per se in fetching gobs of rows. We're not trying to pull 100,000 rows over the wire into your application and breaking the bank with that. We're not talking about that. But we're talking about what is the consequence of this guy right here. In fact, if we're going to do this, I'm trying to get the hang of this guy. Okay, yeah, okay, it's a little two-dimensional. So this part right here, what we're talking about when you do that, you're saying I need every column of the table. Okay. Now, what's a good table definition? Actually, I happen to have an example right here. I'm going to use let's move this layer way up top here, and I'm going to add a new layer. Okay. Let's put a new layer on top. And let's look for a table definition. Okay, let's go back to black. Okay, so we've got, let's not do it that way. Let's do a create table statement. Maybe that's a little create table book. Okay. Let's define the columns here. Okay. We're going to need some kind of identifier. Now I've said you can either call it an ID or book ID. The full contextual name of this is whatever your schema is or whatever the database you're in. So in this case, our sample app we call it the Bookly app. Okay. So it'd be bookly.book. Okay. This is the book table. And so this column would be book guide. So this would be the full resolution of this guy is bookly dot book dot book dot book ID. So in that context, maybe it sounds repetitive to put this extra clause on here, but I'm actually going to say most of the times you're dealing directly with the columns, and so it's okay to just stick it in here. So you have a book ID, let's call it a UUID because we're in a distributed system. We're not going to go into why you want to do that. Go check the channel for more of that. It's a primary key. So it's a primary key, and there's a function, I'm not going to go into elaborate details, to generate a random UUID every time you insert a row, okay? Let's say we have a title. That's a string. We're going to have, in this case, we're going for a simple one. I'm not going for some multi-table complex thing. We have an author string. Let's say it's a bookstore, so the book has a price. And we'll pick float. We don't need to go into all the depths of details about floats versus decimals versus pennies, whatever. Just we got a price. Let's go ahead and lay out a format because we sell ebooks, audiobooks, you name it. And then we're going to have, publish date. Okay, so we're going to have some kind of date field, okay? And that's our entire create table thing. Okay, so we started off, we have what, 1, 2, 3, 4, 5. This is 6 columns, okay? And this is reasonable. This is an example. This is an example table, but when you get to production, I bet you can sit down and it's not hard to come up with more ideas, more columns that you would actually need in an operational thing. Like, I said bookstore, another analogy I use a lot when I talk about relational databases is libraries. And in libraries, you have states like what's the state? What's the status of the book? Is it checked out? Is it on back order? Is it on loan from another library? If we get into like a bookstore, we can start thinking about, we need ISBNs. We need copyright dates. There's a published date, but what's the copyright date? The book may have been copyrighted 10 years before the published date, that kind of stuff. If you go to any of your other existing favorite bookstores, none of which I will mention by name, you can look and see a lot of other characteristics. And if there's anything that's truth, it's that this structure right here is going to evolve over time. So right now, when I say select star, I'm saying, give me all those columns. But what happens when we start with 6 columns and it evolves to 20 columns or 30 columns or 50 columns? There's operational actions that are going to happen with our bookstore. Someone's going to come to us and say, we need to expand the definition. We need to grow it. We need to alter the table. And this column, all these columns are going to evolve. What's the outcome to our application code? And so what happens? Now let's start off with, we talked about, in our sample query, it's reasonable. In our sample query, we're fetching one person here. Okay. So this is an example of somebody's coming to your app and they're looking for a specific author and they want to find, well, show me all the books that they have. Unless they're finding somebody like Isaac Asimov, who even Isaac Asimov published hundreds of books. That's not a heavy load on the system. So maybe we need to think of another use case. Maybe you're integrating with another third-party service, some other business app, whatever, is wanting to come and connect with our system. They're willing to pay us for access through an API, and they're basically wanting to pull 100,000 rows, 1 million rows at a time, something like that. They want a bigger chunk of the data, okay? So we need to deal with that. The question arises, well, if I'm doing a select star, I'm fetching every column. Now, I just showed 6 columns, and they're not that big, but you can think of tables that have more complex data, more extensive data. We can start talking about 30 columns, 40 columns. I have seen tables that have evolved over a 10-year period to reach the point, especially if we're talking about, don't delete a column, okay? I mentioned that at the beginning. There's reasons to not delete columns, maintain columns, because you are not in control of when those other apps go out of scope. So they may still need to be talking to old columns. I've seen databases where you get to the point there's 200 columns in a given table. Okay. If someone's coming and doing a select star, they're getting all 200 columns, even if they only want 5. Maybe, you know, what, what if your little AP, come on, come on, Procreate. Okay. Um, yeah, I use the app Procreate for doing this stuff. It's my little art drawing tool. Let's go back into it. In fact, let's do it like this. Okay. So, through the API, this third party service, they're doing their own query. Let's pick a nice, calm, and relaxing purple. Okay. They could do select start, but what they really want is title and price. And then, there's going to be something else in here to help flange down on the fact we're not going to let them pull the entire repertoire in one fell swoop. We could put in some kind of paging solution, okay, to make it more reasonable. And we can look at some tactic, maybe we can integrate with logical data replication. So if we know people are coming and fetching the data, they don't need to be hitting the operational 5-node cluster that we're running spread across 3 regions, okay? That's a huge cost to the enterprise. So instead, maybe there's a replica that's maintained with a cloned copy of the database that can serve this kind of thing. And if you're interested to hear me talk about Cockroach DB's logical data replication, then go ahead and smash the like button, because at some point we'll talk about that on a future episode of Select Star. But the idea is this third-party service doesn't want 40 columns, okay? 40 columns. No, they don't want that. They just need that for whatever reason they're doing. I'm sure you can, if you stop and think about it, you can imagine a use case where you're integrating with them. They're paying for access. Maybe they're listing the stuff in a third party, some market. There's a market. They're agreeing to list it, and the deal is every purchase that comes through from their system that comes into your bookstore and orders it, you're willing to share 10% of the purchase price or 10% of the profit after costs are paid for. So it's some kind of affiliate link, and they need the basics. Maybe they need title price and whatever the description of the book is. Okay. So you don't need to fetch 40 columns, because what does that look like? So if you've got a gigantic, if you've got this table and it's got, 40 columns, like, what does that look like is the blob that's traveling over the wire? Okay, let's zoom in here a little. You've got this blob of data, and it needs to zoom over the wires, long distance. Okay, some kind of long distance network connection. What's 40 columns of data going to look like if you're fetching, what if the agreed upon size was you say, well, I can serve you 100,000 rows per chunk. Okay, that's our chunk size. I can do that. So we're going to fetch that to Mr. Third Party Service here. Okay, so they're going to ship that over the wire, and that's a big chunk of data. Okay, but what if they only need 3 columns? 3. Well, that would shrink down the thing. So the whole idea is the first reason to not use a select star is and only select what you need. Sounds like a TV ad for somebody. Sounds like you can drastically reduce your network costs. Now we kind of take it for granted maybe, from a personal perspective, when I go online personally and I'm shopping around wherever, or I'm going online to do something, I don't think about bandwidth costs. Okay. But when you get into commercial grade stuff, fundamentally, somebody is paying for the network. Now, you know, through my house, through my home, well, I am paying for it and I'm allotted a certain amount of bandwidth. I'm given a certain amount of bandwidth. But if I want to go above that, if I'm going to be a third party service talking all the time and fetching data, I may need to buy or rent a bigger pipe to handle this. I need to size this appropriately. If this third party service is going to be hammering our system through this API connection, I need to build that into the price. I need to figure out what the cost of it is to be working with this. I'm not going to, my shop here on the left-hand side of this link on the relationship, I'm not going to eat the full cost. I want to have a reasonable exchange of value here. So we want to trade the bookstore, but there's a certain, we want to offer links for them to be able to buy our books through this service with an affiliate deal. But I need to, first of all, I'm going to price in the cost of the books themselves, but I'm also going to factor in the price of the bandwidth that they're eating up. And one way and that's a fixed cost. I'm going to say, well, look, first of all, we got to agree to the fixed cost of the bandwidth. If you're fetching this much, this is what the cost of bandwidth is on our end. So we need to split it equitably, whether split it in half, whatever. We need to come up with an equitable deal. So we're going to agree to the cost of the bandwidth. I would love anywhere possible to shrink fixed costs. That right there is a fixed cost that I'm taking on to provide this affiliate service. So if I can shrink the cost by reducing the number of columns, maybe shrink it from 40 to 3, that right there is going to make it more efficient. It's going to let us, there's no need to pass, we probably don't need to pass the copyright date, that kind of stuff. Now, what's that? What's the cost of the copyright date? Is it really that big of a deal? Is it really that big of a deal to trim out, these columns? Any one column you could say is not a big deal. Okay. It's not a lot. That column's not a lot. This column's not a lot, but stuff adds up in the aggregate. Okay. There's a multiplicative factor involved. If you're saying, well, it's not a lot, but I'm fetching 100,000 rows in the chunk size. The idea is they want to put up, maybe we have 10 million books in our database for sale, and they actually want to be able to offer a significant portion of that. And they're not going to fetch it one time. It's not a fetch it one and be done kind of situation. It's going to be multiple times that they're going to come into our API and want to get this data. They want to access it. So the cost of those extra 37 columns, whatever, is going to add up over time. There's no need to go pay that cost if we can alter our select statement and flange down to give just what they need. Okay. It's when you get into database performance, there's typically kind of two avenues where you need to go through when you're optimizing stuff. One of them is you're looking for those queries that are taking seconds or even minutes. Okay. There's some 30-second query that is part of the user's interface. Okay. They're going through the web page or the thick client app, whatever they're doing, and they're fetching content or something to make a decision on what to do something. Well, if the query that has the contextual knowledge is taking 30 seconds, that's directly visible to the user. Okay. So you want to find those queries and fix them. You want to optimize them. You want to make them go sub-second where the person doesn't notice it. Okay. That's one form of optimization. And also there's another form of optimization where you have this query. It's not 30 seconds. It's 80 milliseconds. It's almost nothing, but you're running that query 100,000 times a day, whatever reason. It runs 100,000 times a day. And if you could shave 10 or 20 milliseconds off that, a microcosm of the first scenario, if you can shave it from 80 to 60, when you multiply that by 100,000 queries a day, that trims down your cloud bill. If you're running in the cloud, that trims down your prem with the sizing of the server you need. That's a cost cutter. Here's one of the things to do right here is to cut down on what you're fetching. And that kind of leads me in to the second point is when I go to this kind of query where instead of fetching all 40 columns of this table, I only fetch the 3 columns that I need. it helps the optimizer. It helps the optimizer figure out what to do. And the thing is, we're talking about Cockroach DB. I mean, I got the insignia here. We're on the Cockroach DB channel, but I mean, this is applicable to any database that you go to. Okay, every database engine works differently. They're all unique. They have their benefits. Hey, I like ours. I hope you like it too. And anything, any information, any context we can grant to the optimizer through the SQL that we write helps it do a better job. Um, you know, it's always better if the optimizer knows, oh, we're looking for these 3 columns. Cockroach DB happens to have this feature. Cockroach DB happens to have a feature called column families. If you didn't know it, under the hood, Cockroach DB is fundamentally a key value store. Okay, it takes, there's a key which principally maps to the primary key, and the value is the content kind of serialized together in a specialized format. It's not complicated. But what happens is if you want to fetch it, it has to kind of deserialize the content. Well, if you're having to make updates, you have to go update the entire value that's stored there. If you're updating a single column's value, it has to update the entire value that's stored in the underlying key value store. Okay. There's a concept where some values hardly ever change, or some columns of your structure hardly ever change. And in fact, they may only change in the sense that they're created one time and then they stay put. Like, for example, primary keys really never change. Now I know there's exceptions to that, but primary keys typically don't change. There's other values that change at a low rate. And then there's stuff that changes at a high rate. Okay. Like, every day or every hour, or every minute, that kind of stuff. There's a lot of, there's different amounts of churn. And what column values let you do is, instead of having a single value stored in the underlying key store for a given row of data, you can break it up and say, here's the amount of here's the columns that never change at all. Let's set them in one value. Here's the columns that have some amount of churn, and here's the columns that have lots of churn. Instead of a single value mapped to the primary key, we can break it up into 3. So the only updates are here. And it can be what this thing is fetching, what this service is fetching. If all 3 of those columns happen to be in a single in a single column family in Cockroach DB, then the underlying data store, the key value store, only needs to fetch and parse that part of the system. Okay. It helps it work better by not having to get there. One of the other columns that may change a lot, or it may not change, maybe it doesn't change at all, happens to also have a big chunk of data. And if you don't have to contend with that, that's great. The whole thing is by giving more context to the optimizer, but to the engine, it's able to do a better job at figuring out what to do here. So, it's just better to give as much semantic information as possible. This is the other reason why, it's not the point of today's Select Star episode, but it's also a key reason. Make sure we're clicked here. Okay. It's a key reason that you want to provide the where clause instead of fetching all the data back to the app and letting the app filter it out. If you can feed the additional where clauses to the optimizer can shrink down the number of rows and make the results more performant. All right. Now, one thing I want to let you know about is we've got some we've got more content coming out. We've recently updated our Cockroach University webpage. So after this episode, go check it out, and you can see everything that we have at university.cockroachlabs.com. And you can actually have an opportunity to take it for a spin. So there's some really cool stuff there.
If you're enjoying the show about the database you just can't kill, then give it a big thumbs up and share it with a friend right now.
Now, the third reason, let's go into, this is kind of, the first 2 reasons I gave are absolutely, valid, legit. It's a key thing to do. But to me, the real reason that you want to not ever use a select star is because you really need to guard your application for maximum compatibility. Okay. What are we talking about here, Greg? What is that? Okay. I kind of gave a little bit of a clue when I talked about the compatibility stuff earlier. When I talked about stuff changing, stuff evolving. Let's go back to our select. Okay, select star from, let's go back to our badly written query. Where author, I'm going to show you this query. Okay. Haha, I don't have it up. Let's fix that. You're not even following what I wrote. Okay. Y'all love my chicken scratch. If you do, be sure to smash the like button. Okay. So this is going back to our select star. We're filtering on a single author. Let's say we went to production with this. Manager comes in and says, "Hey, that ain't good enough. We need to evolve this. We need to evolve the schema. What are we going to do? Okay, we need to alter the. Come on. There we go. We need to alter the book table. We're going to move in a new direction. Author. First name. Author. Author last name. Okay. We need to split that up. Now, and the rule of don't delete a column, you need to hold on to the author column. But what that means is you really should write, the query needs to be rewritten. Let's pick a nice, it should really be select, and you can't, that word. Okay. Here we go. Select title. Instead of saying, okay, we can select the, we want title, description. I think we said price. Okay. So for that third party service from book. See, we need to be doing where author first name equals Greg and author last name equals Turnquist. Okay. So an author last name is Turnquist. So you need to expand this, but the thing is, what happens if you're doing what if you're doing select star? Here, let's do a little erasure here. You're doing the good old select star and you've evolved the database. What's coming back to you? What do we need? We need another layer. Yes, we need another layer. Okay. If you're doing select star, you're getting book ID. Now, we've got all these we talked about 40 columns. I'm not writing down 40 columns. Let's focus on what's relevant here. Okay, you're getting the author column. Let's just say this is book ID 123. You're going to get Greg Turnquist in the author, in your backwards compatible author column that's being maintained by either the DBA or the app managers. You're also going to get, let me just shorten it and call it first name. Call it first and last. Okay. So now this is what's coming to you. What's being sent to you over the wire is you're going to get what you asked for. Well, I don't have the title in here, but you also get the title, the price, which hasn't evolved yet. And you're going to get this author information twice. So that's not efficient. We already talked about, cutting your network costs. So you're sending the same data over twice. Okay. But now we're talking about maximum compatibility. What does your application do with the data once it comes over? Are you mapping it onto some kind of domain object? Is your code, I don't know if you're using Java with Spring. I don't know if you're using TypeScript, Python, whatever. The same principle applies. You're probably taking the data that's coming back to you from the database over the wire, and you're transforming it into some kind of object and in some kind of thing. What happens when you get both an author name, an author column, and an author first name and an author last name? Well, hopefully it doesn't break you, okay? Right off the bat. It's not uncommon for somebody to write an app and say, just map it to the object. And then as soon as the database evolves, collision, or it breaks them. Okay, that was not smart. Let's fix that. But you need to at least make your mapping logic handle that and say, I've got name, I've got author name. And if a column shows up that I don't recognize, throw it away, ignore it, just chuck it. Okay. So either you're mapping on this column, or you came in, maybe the app you're dealing with came in and is using these two. Okay. You're using the first name and last name because you came in new. The truth is there's probably a mixture of apps. There's some apps that are using the old stuff. There's some apps that are using the new stuff. Now you see why you need to not throw away columns. The point is you sent multiple copies of data over the wire. That was part of your network cost, but you're now putting apps and reports and things like that at risk from a compatibility perspective. There's a chance that there's probably more than one application that's talking to this table throughout the enterprise, and it's probably not just yours, but it could be yours. And if you're doing the select star, if you're fetching every column and running with it, you run the risk of not handling something and it breaking you. There's another aspect to it is you can even have, the thing is SQL gives you the ability to roll with the punches, because you can even do, let's pick something a little. SQL can be your integration layer, because not only you can sit there and say, well, I want the title. Let's say I need to put the name on. So I'm going to get, so first name. Let's say that your app is still stuck with, let me back up. Let's do a big erase on this. Okay. All right. Okay. Let's draw the object that you're trying to map to. So this is your object. Title, author. So this is my object, or it could be, this is the application's logic. I may not own that definition. Some other sub team or some other group may own this definition, but the SQL that's being used to populate that, I do have control over. I can do, it used to be I would do select author, comma author from book, whatever. Okay. But I can tweak this guy. I can alter this guy so that now it's select title, and then I'm going to use a concat function. Okay, so I can grab first, comma, space, comma, last. And so right here, let's zoom in here a little. The SQL, I can kind of get it to fit into the author. Oh, let's put as author. Okay. So the second column, it's going to come back with a funky name if I don't do that. So I can get it to fit. So I can massage the data. So I can get this to fit into this object, and I can get this to fit into this object. And this is where you start thinking about how to make your stuff compatible, how to make it work together. So in this sense, I want to think carefully about how I'm using the data. SQL, fundamentally started off as this idea of a reporting technology. It was like a way to kind of generate reports. But we've seen it in the past 20 years as a way to actually have operational data. We have systems that talk to each other, that integrate, that carry out high volume transactions. And that's one of the reasons, some of our biggest customers that come to us have this kind of high volume traffic. But you can look at it as like, I'm just taking data that's in one format and I'm transforming it to fit into another format like this. But when I do select star, I'm kind of taking the simplest parts of that and sort of throwing them out the window and saying, no, thanks. Whereas if I focus on compatibility with interacting with the SQL, I can make it fit together. And then this opens up the door, down the road, they can finally say, okay, we can actually, the application code's ready to pick this up. Okay. It can finally migrate to first name and last name. Now, if you enjoyed this, I invite you to hit subscribe and ring the bell. That way, the next episode of Select Star, when it comes out, you won't miss it, because we want to go into deep dive on some of these nice technical things here. We want to find out about the database you just can't kill and how to make it work best and serve you, because that's the whole point of having a database. You're not there to serve the database. The database is there to serve you. As long as if you can adopt some good principles and fundamentals, well, actually, it will be a party. All right. Thank you, and I will see you next.
This episode is over, but your learning has just begun. Visit cockroachlabs.com to find all kinds of content to expand your knowledge.